Welcome to the Team MakeyMakey Project Architecture Review. As the session description states, this presentation will detail the MakeyMakey as a learning record provider and an enabler of alternative input devices that trigger an xAPI statement to be sent to a learning record store. We will see a demonstration of the project's functionality, detail the design considerations for a learning experience designer to consider, and review the architecture used in construction and elaborate the components for project reuse. In the document xAPI, a guide for technical implementers, we are presented with three definitions listed as core technologies enabled by the xAPI specification. First, a learning record provider, or LRP. An xAPI client that sends data to the learning record store. Often, the learning record provider will create learning records while monitoring a learner as part of a learning experience. The LRP is any source of xAPI data. Second, the learning record store, or LRS. An LRS is a server or system capable of receiving and processing web requests that is responsible for receiving, storing, and providing access to learning records. The LRS is the system of record for xAPI data. Third, the learning record consumer, an xAPI client that accesses data from learning record stores with the intent of processing the data, including interpretation, analysis, translation, dissemination, and aggregation. LRCs include any system that consume xAPI data for any purpose. Remember, xAPI statements may be stored, exchanged, and consumed by the core technologies enabled by the xAPI specification. In this project, we will review building a learning record provider. The MakeyMakey LRP is made up of web technologies, the live code application, the MakeyMakey printed circuit board, and a learner response device, such as a ping pong ball board, arcade joystick and buttons, the Monogram Creative Console, or Raspberry Pi Zero with a joystick Pi hat. The web technologies, commonly referred to as a stack, include HTML, CSS, JavaScript, and JavaScript libraries. All of these exist as files on a web server, in this case Mac HTTP-JS. These have been tailored via custom JavaScript to send statements based on inputs received from the MakeyMakey. The local URL is literally pointing at this, so the other machine is running this server, and if I come over here to my active tab, this is the actual page that's running. So if I do a reload, we should see some data scrolling back in the background that it's actually loading the pages.
Okay.
And there's a couple errors, there's no favorite icon and a few things like that, but it's showing you it's loading this index, CSS, JavaScript. So this is a JavaScript library called Crypto.js, a JavaScript library called xAPI wrapper.js. Part of that xAPI wrapper is this project JavaScript, the CSS, and the JavaScript for visualizer part that I added in, and then there's a PNG file that just adds spacing. And so the architecture is we're either going to this local web server or we're going out to the remote web server that I've been showing you.
Yeah.
And on the local one, the advantage to having this visible is I can go into mission control, switch desktops, and see the structure that we're looking at. So the web folder on this other laptop is showing that within MakeyMakey we are looking at the path of, so within the local URL, we're looking at just MakeyMakey/visual and the index file. So this is the folder we're using, is visual. We right click on that and open a new tab. We're using the index file, which then pulls in the JavaScript and CSS. That I'm going to open with BBEdit. And there we see our structure again. So back to the HTML file. We should see similar headers than what we saw before. So I'm down here to this body section. And now we should see the correlation with what you're seeing here.
Okay.
These progress reports and the header text. So all of that is static text. I've got some links in there to allow people, once they get access to one of these pages or the app, when they're running the app, you can actually scroll back up in here and use the links.
Okay.
So if I clicked on the cohort, you can click on the GitHub. It's going to take a moment to load, so I'm going to continue on while it does that. But that's part of why I have these remote and local buttons, is as that loads and shows you the other pages, you can use the remote and local button to return back to the server side. So yeah, you can see it's loading rather slowly. My internet connection is challenged. The other key pieces you see here is ready, is what is shown as output within this page when it initially loads. So let me do a reload. You can see our ID is no longer available. So down here we have ready as status within the actor. So I'm literally sending that manually to let the JSON structure be built. But it's just to show that the page is ready and you can send the statement.
Okay.
And let me bounce back over. So I clicked that link. This took us to the MakeyMakey wiki.
Yeah.
So the idea is someone who has access to the app can then see where the source files are. So there's quite a bit of detail that I've added out there. I'm going to click remote to get that back off the screen to catch us up with where we're at here.
Yeah.
Switching back. So now we get into the case statements that allow us to look at what the MakeyMakey board or keyboard is sending. And again, all we're doing within the JavaScript for the HTML is saying, did I hit the space bar? Did I hit the left arrow? Have I selected the up arrow, the right arrow, the down? Or have I selected a letter? And then each of these letters correspond basically with an ASCII character. So the logic within the JavaScript is, if you see case 87, I selected the W, and I need to use JavaScript to tell one of the JavaScript libraries we're using that the W was selected. So as we switch back into the project file, we'll see what happens when each of these is selected. And because of the file structure, there's a little bit of abstraction there.
So are these just ASCII numbers?
Yes.
Yeah.
So this is literally looking for ASCII. And part of what we saw within the live code is there's different structures for if it's an arrow key or if it's a mouse down or the other keys that can be clicked.
Yeah.
If I look over here on the interface, these are the other keys that can be clicked. I can also capture on the MakeyMakey whether the mouse is clicked, the space bar is pushed or clicked, or if they use the arrow keys. So within live code, the structure is different for each of these types of interactions. But within JavaScript, we're just trapping for the ASCII characters. So you can see it's one long switch statement that looks at different cases of which was pushed. We are running, and you can see it's gathering the input and it's preparing the response because my cursor is spinning.
Oh, the A now went. The A's pressed.
Yeah, I see that. Okay.
Yeah.
So now I get the feedback saying I've selected the A key by clicking the red button.
Yeah.
And then once I click OK, again, you saw the scroll bar slightly
Yeah.
change. I wasn't scrolled down to
Yeah.
see the ID.
Yeah.
Well, now if I switch to the web page, you
Yeah.
can see the web page itself isn't updated because it's another instance within a different browser.
Yeah.
So if I perform a different action here,
Oh, you're still in the. You've got the S key.
yeah. So I got the S key. One of the things that occurs to me is when we get into where the script is executing. So the index file connects it to the project.js file. So what we're capturing here is actually sending, I believe I should say activating these functions. I think that's the
Yeah.
right terminology
Yeah.
within the
function.
project.js file. So for select down arrow, let's leave that one selected and go into the JavaScript. Unfortunately, it scrolled down to where I had been. But you can see it's broken up into functions: select up arrow,
Yeah.
select right arrow. And what I've done is manually defined what
Okay,
that
yeah.
JSON looks like for the statement, and then edited the variances. So right now, none of that is coming from variables. None of that is being
I see,
filled by
yeah.
values in a field.
Yeah.
But that's part of what I'm looking at is instead of just assuming we know who the agent is and assuming we know the background, if we expose some text fields
Yeah.
in the live code, I'd want to be able to fill in that name, mailbox information into a variable. Actually, it is coming into a variable. The variables are set up here,
Yeah.
but I'd like to be able to replace that with values from the field rather than the variable values.
Yeah.
The other key thing to know is when we hit this function, when I've selected the up arrow and it's gone through the HTML, it's being sent here and triggering this. It's setting a variable called up arrow statement and filling it with these values, and some of the values themselves are coming from variables.
Yeah.
But the remainder of that up arrow statement is then being sent. I shouldn't say remainder, but the comprehensive value is being sent to the xAPI wrapper through the send statement. So this is the JavaScript that's actually triggering a statement to be sent by going out to that library. So it's going out to the xAPI wrapper.javascript to perform that function.
Yeah.
So that's the next stage. And then the rest of this file is just case statements. In a sense, we're looking at each function and determining what the values are. So in order to rapid prototype this, again, all our JSON has been replicated for each function rather than having values that are coming from variables based on the dependencies.
Yeah.
And then like I said, I've replicated that, but you can see some of these certain ones are getting longer and better values. So we added context into the details for the W selection, for example. I've added in, and this is what we were viewing down here, I've added in the actor details with a mailbox, the agent name, the actor name, I should say, and object type is agent. So this is where that's coming from. The verb is selected, the ID is selected, and then the object has some variance in it between the different answers, but for the most part, the actor and verb is replicated. But based on the object, we're actually defining that this is where the color comes from. So select W equates to blue, and question 27 is static based on that ping pong ball board I showed and the question number that's answered. So at this point we're answering one question. So all the JSON in here is replicated with question 27. In this next section, we'll see a brief view of the English-like scripting language for live code. This section includes a more detailed discussion of the architecture behind the MakeyMakey project. First, let's see the user interface for the integrated LRP application. On top, we see the web browser. Below is the simulated MakeyMakey board, and to the right, the extension board which assisted in connecting the beta learner response board. We've already discussed some of the web technologies working behind the scenes. Now we'll see how the live code application is structured.
Yep.
So this is actually the app that we created.
Okay.
And down at the bottom is a representation of the MakeyMakey board. And when the app is running, it'll load the web screen in the widget up at the top.
Okay.
And I can click on the icons here that I have buttons over the graphic. And then I also have this little extension board that I found that allows you, without getting into wiring on the back of the board, it allows you to just use the alligator clips again for additional letters. So this let us do some extensions of what that board looks like. If I use the keyboard or the MakeyMakey board, I can then get the feedback that I've selected the W key by clicking the blue button. I'm literally sending a response to the MakeyMakey board, and it will send this response out to the server through the live code. And you can see now we have an ID. So that tells us that we have actually sent a selected statement, an xAPI statement that indicates that something was selected. So there I hit the red button. I'm seeing that I've selected the A key by clicking the red button. And once I click OK, it actually will revise what we're seeing on the screen.
Okay.
And that shows me that that has been sent. So I'm using a visualizer JavaScript library that I mentioned here, the visualizer and the CSS for that.
Okay.
And that reformats that JSON that has been sent and received back from the server, or the LRS, and allows me to sort of drill down and to see what the statement looks like. So here's the agent, the actor that we sent in. Here's the verb that we sent in with an ID for the verb selected. If I hit display, it tells me that that is selected. And because of the structure of the JSON, you're driving down into these items. But you can see that I answered that, I should say, our actor, Anna Johnson, has selected red for question 27 in response to this question.
Yeah.
And if I scroll down further, the correct responses pattern tells me that it should have been yellow.
Okay.
And the choices included 0 through 3, so 4 choices. And these showed me what are active within the statement that we're sending. And then the activity detail allows me to see that they completed the activity. The success level was set to false because they didn't match the answer and the correct answer. And then the context here adds us some additional details. So we added in a category, a parent. So the category includes the object type of activity. Both the category and the parent. And then the definition has these additional attributes: an assessment and our formative assessment. We identify the instructor, so we're adding quite a bit of context to the JSON that's being sent back to the LRS. So part of that is saying our team is Team MakeyMakey, and we're identifying the platform as the question response app. And this overall ID is the statement ID that the LRS has sent back. So when we send a statement, the LRS answers back by adding that ID, and that can be used for the query. And in the sense, we're sort of set up to do those queries now within our HTML. We've pulled that data back in and are displaying it. And now a bit more detail on the MakeyMakey board. The MakeyMakey board started as a project by 2 MIT students on Kickstarter. It functions as an invention kit enabling students, teachers, inventors, and entrepreneurs to design and build interactions with objects that can be captured as keyboard input to the computer. The silver area and holes through the board allow physical wiring with alligator clip connections. Each arrow or button, shown as circles, act as a starting point for a single circuit. There would be one wire with a pair of holes for the alligator clip to byte, then connect to a button, and another wire would return the circuit back to the MakeyMakey board's ground holes, here marked as earth. Each button has the same wiring, but by starting from a different position on the board, they will respond only to that button. The additional features of the arcade box required an extension to the MakeyMakey board, known as the WASDI-FIG board, which adds extra contacts without using the pigtail wiring or soldering. The purpose of this board is to add additional alligator clip connections to appear beside the MakeyMakey for wiring the additional buttons beyond the silver connections shown earlier. Our first prototype response board was designed as a physical input device for developmentally disabled individuals. The MakeyMakey board was connected to a ping pong balls. Check. The MakeyMakey board was connected to ping pong balls that had been held in place via aluminum conductive tape and mounted on a marker board that was cut to size. Keep in mind this image shows how it looked in development by the MakeyMakey team, not how it would have been presented to our audience. Here we zoom in on the board. The learner response board was the alpha prototype. This board was built on a 15.5 by 12-inch section of wet whiteboard materials from Home Depot. We laid out space for the survey questions to be taped on the board and the answer buttons to be aligned under the associated buttons. The buttons are ping pong balls that were cut in half. After separating ping from pong, we then alternated ping and pong halves and wired with aluminum duct tape. The tape was partially routed to the back of the board for half the circuit. The other half of the circuit is shown in the image, and it is wired in the front of the board. As a result of the limitations found in the alpha response board, we were able to locate components for an arcade joystick and button box, which we repurposed for use with the MakeyMakey. Amazon and eBay parts were used, estimated to cost about $50. The features of this setup includes accepting input from push button or joystick. It's wired for a 6-button response directly to the MakeyMakey board, and the software was revised to accept responses from the joystick and top buttons as well. In the next few screens, we'll show some potential learner response devices based on emerging technology. The Monogram Creative Console is a recent Kickstarter project that brings physical implementation of common user interface elements such as buttons, dials, and sliders to life as real USB-enabled input devices. While there's likely added program required, the Monogram Creative Console is available for order today, and the software provided allows mapping of the UI elements as input for common desktop software applications. The smaller form factor of the Raspberry Pi Zero and its wireless operations indicate that a wireless design could be created with similar inputs as the MakeyMakey expects. This Pi Hat, as it is known, features a joystick, directional arrows, 1- and 2-player buttons that directly align with the MakeyMakey configuration. Lastly, the Touch Pi Hat on the Raspberry Pi Zero is enabled with 4 lettered buttons and backwards and forward buttons. These likely could be remapped to enable a different interaction than the other devices shown, but would likely require a bit more effort to reuse the MakeyMakey software. The left and right button configuration, as well as the letters A, B, C, and D, would allow a user to progress through a series of screens or series of questions and respond to each one. Earlier, we showed this image of the xAPI core technologies, so here's a reminder. In this case, we're focused on the Learning Record Provider, or LRP, and how we'll send statements to the LRS, or Learning Record Store. We've removed the Learning Record Consumer to focus on the interaction sending a statement from the LRP to the LRS. We're barely going to mention the LRS as we continue, so I'll mention it now. There are a number of LRSs in the commercial space. Many have provided extended trials for members of the free xAPI cohort. Some of these vendors and the ADL itself make a subset of their LRS tools available as open source software that can be installed on your server for the lowest cost LRS. Our learning record provider is a chain of technologies working together to send a statement to the LRS. In the following screens, we'll elaborate each of these. First, the learner response device. This allows student interaction or input as a starting point in our event chain. Typically, the learner response device collects input from a student. A learning record provider may also be used by a teacher to send assessments and evaluation data relating to a student. The MakeyMakey receives input from the learner response device and converts it to a USB signal that the host computer can use. The LiveCode app receives USB input from the MakeyMakey, presents the MakeyMakey user interface, and animates the input that was received. Then it sends a statement to the LRS, and finally generates a JavaScript alert to indicate that a statement was sent. So, all these technologies working together are acting as our learning record provider. This is not the only configuration that would work. A user interface built on the web application or in the LiveCode project would allow a statement to be sent without using a learner response board or the MakeyMakey device. In that sense, there are components used in our project that can be pulled down from GitHub and used in future projects without any dependencies on the earlier technologies in the chain. Our earlier LiveCode iterations are published to GitHub without code for MakeyMakey in case other teams wish to use them for their projects. LiveCode is available as a LiveCode Community Edition, which is an open source edition available for free download and can be used to develop standalone applications. Deploying applications specifically to the iPad or iOS devices would require, a commercial version of the software. Our application can be built or modified using the LiveCode Community Edition. In conclusion, we are grateful for the support of the Torrance Learning team and those who have supported the xAPI cohort, the download, and the xAPI party. Thank you for your time.